Okay, what does this machine behind me do? This machine measures the heavy and light isotopes of oxygen, oxygen 18 and oxygen 16. And the reason that that is such an important thing to do in ice cores is because the ratio of those two isotopes gives us temperature in the past. So when we take an ice core from, say, 100 years ago, and we melt it in these little sections all the way up to present, we get these little subsamples that we can put into this machine, and the oxygen isotope ratio from each of those little samples will translate into a temperature. So in this example, we get a 100-year temperature record. Now, on a longer scale, glacial, interglacial time scale, the data that comes off this machine gives us these long-term temperature records. And that's very powerful. And one way that's powerful is that we can see, normal glacial, interglacial temperature cycles, and then we can see anthropogenic impacts superimposed on that in our current, the Holocene. So when we have these very long-term temperature records, we can see when there's a deviation from that. We can see the impact that humans are having, which is superimposed on natural climate variability cycles. And so the other thing that this instrument is very powerful at doing is combining it with other ice core labs that measure the gases. So in ice, this measures the liquid chemistry when we actually melt the ice, but there's also air bubbles trapped in ice, and we can measure all the gases that are in those trapped air bubbles, and they're these little ancient snippets of atmosphere in the past. And this is actually why we know that an increase in CO2 in the atmosphere causes an increase in temperature. It seems like something everyone knows these days, but this is why we know it, because you can measure the oxygen isotope ratios with this machine. You can measure the CO2 trapped in an air bubble in that same sample, and then you get an atmospheric CO2 time series, the liquid chemistry oxygen isotope time series, and they trend together. So an increase in atmospheric CO2 causes an increase in surface temperatures on the Earth.